So, hello everyone, I am Vikas and I welcome you all in this post-contest discussion of CodeChef Starters 249. So, first of all, let me check if I'm audible and we will start the discussion in less than 1 minute. Yeah, also, can you share in the live chat how many questions you solved in the contest today? Hello, Cube Decoder. So, you only got one question right out of seven. Okay. Yeah, I mean that happens. So it also happened with me when I was a beginner. So just keep solving and also uh keep solving keep up solving every contest. Like what was the reason that you were not able to solve the question? And yeah, also the point is that you solved one question. So now you will learn more from this contest than me, right? Because there is so much to learn for you. Yeah, okay, so let's start the discussion by solving the first question, which is varied digit. Yeah, it was again very easy. So we are given a two-digit integer, which is called varied if it has two different digits, else it is not varied. So it is like for the 22, we can see that both digits are same, so it is not varied. And here you can see that both digits are not same. So yes, it is varied, and that's what we have to do. So let's discuss this. Yeah, so this is our question A, and we are given a two-digit number. Let's call it n, and it is a two-digit number. Uh, now, first of all, let's say the number is 32. So we have to find that what is the digit here and what is the digit here. And in case you don't know how to find the digits, so there is a simple method. So when you do like x modulo 10, this thing, it will give you the last digit, right? Last digit. So yeah, there is a simple method. What is that? So let's say the number is like 123. So if you do 123 modulo 10, you will get 3. Then you have to do then you have to divide this number by 10. So then let's say you do 123 by 10, so it will be 12. Now you know how to find this digit, right? You will do modulo 10. And when you will do 12 modulo 10, you will get 2. And now you have a 12. You will again divide it by 10. So you get 2. And when you do 2 modulo 10, you get, sorry, it is 1. You get 1. So yeah, you can see that from this method, you can find all of the digits. So, okay, so it was just a easy thing. So let's say the number is like A and B, right? It is a two-digit number. So this B, let's say the number is X. The number is X. X is equal to A, B. This is our first digit. This is our second digit. So we know that if I do X modulo 10, I will get the first digit, right? The smallest digit. And then when I divide it by 10, I will get the second digit. So, okay, sorry if I was so fast. Okay, so like this is the method of finding each digit. Let's try. So let's say the number is 23. So if the number is 23, if I do 23 modulo 10, I will get 3. And then if I divide it by 10, so 23 divided by 10, I will get 2. So now you can see I got both of the numbers, right? Both of the digits. Then I will just check them. Are they equal or not? If they are equal, if they are equal, then I will print no. Else, I will print yes. Okay, so that's it in this A question, and it was, yeah, easy one. Okay, 4, 5. This was my first contest, but the contest questions were hard. Okay, yes, the this contest was definitely so hard. Solved 3 questions A, B, and D, but C seemed too quite difficult. Which question was C? Okay, this product exceed. So like this question was based on a fundamental like observation. I mean, there is a fundamental property that we will discuss later. Four. Okay, that's good. So yeah. So everything clear about the question A? If it is clear, I mean, then you what will be the code? This is the code. See, what we do here is that first of all, uh, this is our input x. So the first digit is going to be x modulo 10, right? And the second digit is going to be x divided by 10, right? So let's say if my x is equal to 49, then what my first will do? So the first will be equal to 49 modulo 10, which is 9. And my second will be equal to 49 divided by 10. That will be 4. And then I check, is first not equal to second? If that is true, then I know that these are valid. So I just print yes, else no. Okay, that's it in this question. Yeah, let's move to the next question. If you have no doubt in this, C was brute force. Yes, you can also solve this by brute force, and there was also a optimal solution. I just use if modulo 11, then no. Okay, yeah, this is also okay. This is also a really good technique. I just like try to think fast in the contest. So okay, this is also like, yeah, what Reese is trying to say is that just see the number, like which numbers are same, like this 11, 22, 33, 44, 6, 66, 77. All numbers have one thing in common. They are divisible of 11. So yeah, this is also true. Like you can check if this number is divisible by 11. If that is true, then they are not valid. So then print no. Okay, this is also okay. Really good technique. Yeah. So if this is clear, let's move to the next question of our discussion. So this is buying GPU. So our chef wants to buy a GPU, and like the cost of the GPU is X coins, and we have initially 0 coins. And every month, two things happen in order. So the price of GPU will increase by Y coins, and after that, on that day, on that month, I will get Z coins. Okay, and I will buy the GPU as soon as I have enough money to buy that, and I have to like find how many months it will take to buy the GPU. And if he will never able to buy the GPU, then print -1. So we are given three values x, y, and z. X is the price of the GPU initially. Y is the price by which the GPU is increased every month, and the z is the coins we earn every month, right? So yeah, this is our questions B. So we are given three values. One is x, which is the initial price. One is y, which is price by which, or let's say it is value by which. Okay, just a minute. Okay, it is value by which the price of GPU is increased. And the Z is the money we get every month. So let's analyze some test case and try to find some observation. Okay, this test case is, okay, let's take this one, 5, 1, and 2. So in this test case, x is equal to 5, y is equal to 1, and z is equal to 2. So on the month, okay, let's say these are the month. This is the price of GPU, and this is the money we have. So on the month 0, the price of GPU is 5, right? This is X. And the money we have is 0. On the month 1, the price will increase by 1. So the price will now become 6. And the money we have is increased by 2. So now the money we have is 2. Then on the month 2, again, this will increased by 1. This will increased by 2. This will 8, 9, and 10, and so on. And the money we have is increased by 2. So this will be 6, 8, 10, and 12. Right. So I mean, every month, the money we have is increased by 2. And the price is increased by 1. And what is the first month in which we have enough money to buy the GPU? So like you can see that in this second month, we don't have enough money to buy the GPU. On the third month, again, we don't have the enough money. On the fourth month, yeah, we don't have enough money. On the fifth month, we have enough money to buy the GPU. So on the fifth month, we will buy the GPU. So the answer will be 5 for this test case. Now, how we are going to solve this? So there are like so many methods for this question. One is just using the brute force. So how the brute force is going to work? So what you will do is just iterate on the each month, just iterate on each month and just find that can I buy the GPU at this month? If I can, then buy that and break the loop. Else, go to the next month. That's it. So like the brute force is nothing but iterate on each month. On each month, and answer is the first month on which we can buy the GPU. On which we can buy the GPU. Right. So this brute force can also work. So this will be like O of n, like the number of maximum month it can take to buy the GPU. Okay, and yeah, in this type of question, the first thing you have to analyze is when the answer is -1. This is like very important. Always find the condition when answer is equal to -1. So like whenever I take this type of question, I see this thing initially. So when will be the answer -1? So can you see here? I mean, see, if you just analyze some test cases, and you will find that this price increase is less than the increase price in the like the money we have. I mean, see, this price is increasing by 1 every month, and this is increasing by 2 every month. So therefore, we can reach at this price. But let's say it was like the price is increased by 10 every month, right? Let's say this was equal to 10, and the money we are getting every month is just 1. This is so small. So then we will not able to get the enough money to buy the GPU, right? Let's take the test case. So let's say this is like our months. This is the price of GPU, and this is money we have. So let's say if X is equal to 10, the Y is equal to let's say 5, and Z is equal to 4. So now you can see that this Y is greater than 4. So the price of GPU will be like 5, then 9, sorry, initially this is 10, then every month it is increased by 5. So it will be like 50, 20, 25, 30, 35, and so on. And the money we have is increased by 4, right? So this will be like 8, 16, sorry, 12, 16, 20. So you can see that this gap is increasing, right? So initially the gap is 10, then the gap is 11, then the gap is 12. So now you can, okay, sorry, in this 6, 5, 9. Okay, so sorry, in this the gap is 11, right? So you can see that this gap is increasing. So if this is the case, we will never able to buy the GPU. That's it. So the condition is that when y is greater than equal to z, the answer is -1. This is our first observation. So is this clear to everyone? For the second question, I got TLE. I have to see if you can. Okay, so like if this is the case. Okay, yeah, you cannot use the brute force directly because there are 1,000 test case, and for each test case, I think it should work. Because see, for each test case, the maximum number of days is like 100 only. So maximum answer is 100. So I think the brute force should work, but can you share your code, cube decoder? Okay, so yeah, this was our first observation that when the answer will be -1. If the answer is not -1, then what we will do? So, okay. Yeah, one method is just using the brute force. Also, you can do is like binary search. So you can do binary search. Okay, so in the brute force, this is O of n time complexities. Now in this binary search, like what is the observation? Like see in this test case, this is like on the month 0 you cannot buy this. Month 1 you cannot buy the GPU. So right, but on the month 5 you can buy the GPU. On the month 6 also you can buy the GPU. On the month 7 also you will able to buy the GPU. So can you see that this is like a monotonic function? That initially it is like the answer is no, and then at some point the answer will be yes forever. And you have to just find this. What is the smallest value for which the answer is yes? And this thing can be done by binary search easily. So I mean, yeah, just try binary search by yourself. And the optimal approach, let's talk about the optimal approach. So like optimal approach was about finding that in 1 month, right? In 1 month, how much closer we are getting to the price. This is like we have to find. Let's call this gain, right? So the gain will be the money we are getting X minus the increase of uh, price in GPU, right? So let's take like some test case. Let's take this one only. So in this, you can see that if the Y is equal to 1 and Z is equal to 2, then at every month, like see, what is the difference? Okay, let's say what is the difference? So this is 5 minus 0, this is 5. 6 minus 2, this is 4. 7 minus 4, this is 3. 8 minus 6, this is 2. This is 1 and this is 0. So can you find that like the difference of money I have and the price of GPU? It was 5. Then it reduced by 1. Then it reduced by 1. So this is just the gain, right? I am getting closer to the price. So that's it. And that gain is nothing but Z and Y. So yeah, that's it. So like what I calculated is this gain. So now, like per 1 month, my gain is equal to Z minus Y. What is the total gain I want? Total gain I want is equal to X, right? Because this X is the initial price of the GPU. So that's it. So what we can do is just the answer will be X divided by this Z minus Y and the upper cap of this. Now why this will work? Okay, this may be look confusing to you, and like if you have Okay, okay, I will just analyze your code in just after solving this one. I wasn't able to solve the fourth one. Okay, we will give more time on this. Couldn't solve F1. Okay, F1 was the most crazy one in this whole contest. Yeah. So yeah, this is our answer. I mean, x divided by y minus n. Let's take some example. Let's say x is equal to 10, y is equal to uh, 2, and z is equal to 4. If this is the case, what will happen? So let's write our all the months 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the price of GPU. So the price is like 10, 12, 14, 64, and yeah. And the money we have, so on the month 0, it was 0, then 4, 8, 12, 16, and 20. Again, see, if we write the difference, it will be like 10, then 8, 6, it is 14 minus 8 is 6. Now you can see that the difference is 4. So we only need 4 extra coins. Here the difference is 2, and here the difference is 0. So that's it. So you can see that at each month, we are reducing it by 2. So this will nothing, this will be like 10 by 2, which is 5, right? So that's it in this question. Let's see the code of this. So this is just the input, this is the gain every month, and if this gain is less than equal to 0, then it means that the price gap is increasing. We cannot buy this. So I will just print the -1 and continue. Else, the answer is this. So if you don't know, this is nothing but the upper cap of the x divided by gain. That's it. You can also write this. And then we just print the answer. That's it. Okay. Yeah, this is like count is equal to 0, coin is equal to 0, count is equal to 0, and you take the input, and else while. Okay, yeah, this looks correct. Cube decoder, right? I don't think that this should give the TLE, because see, in each test case, the gain is going to be at least 1, right? And the x is at most 100. So the biggest value is 100, and the gain is at least 1. So therefore, the answer should be 100 at most. And if there are 1000 test case and this 100 of this, so the number of operations are going to be 1e5. Now, I think that maybe the time complexity will be low for this, but this should work. She can be brute forced. Okay, and this, yeah, this is the correct one. And I remember the E question was similar to the one I just solved on the code forces. This one. Okay, yeah, it can be. Okay, let's come to the question C. This was also like a nice question. So this, you can also do the brute force, and you can solve it optimally if you know some property. So the question is that we are given 3 integers x, y, and p in one move. Either we can increment x by 1 or increment y by 1. And then we have to find the minimum number of moves needed to reach the state where the product of x and y is greater than p, or greater than or equal to p. That's it. T is still 1000, and x and y are very less value. They are till 15 only. And the p is still 1e4. Okay. Let's analyze this one. So this is our question C. So we are given two values x, y, sorry, three values x, y, and p. Let's say x is equal to 5, y is equal to 3, and p is equal to 50. So now what we can do is, in one operation, we can either increase this value or increase this value. So now let's say you increase the x, right? So like one way is that you do x plus plus. So now x will be 6 and y will be 3. So now x into y, this will be 18. And the another method is you can do increase the value of y. So then y will be 5. Sorry, x will be 5, y will be 4. Then x into y, this will be 20. And now you have to keep doing the operation until this x into y becomes greater than or equal to p. That's it. So in this case, it is 15. And yeah, we have to give the minimum number of operation to find this. So like there are again in this question also so many options. One is that you can just do the brute force. Okay, like brute force. How you are going to do the brute force here? So let's say you just iterate on each value on like, okay, so just give me a minute. Okay, so the brute force is going to be like, see, let's say x dash, let's say x dash. This is like the number of operation we do on x, and the y dash is the number of operation we do on y. So one thing is clear that this x dash and y dash both are going to be less than equal to what? Let's say 500, right? So like this is 24. So this will be like 10 raised to power 2. Yes. So okay, this x and y dash both are going to be less than, let's say, 150. So therefore you can just iterate on each all of the possible things and just find the minimum among them. So like what you can do is that just this, let's say there we are given x, y, and p. So what we will do is like we will iterate on each value of x dash from 0 to 150, and for all values of y dash from 0 to 150, and see what will be the new values. So the like new x will be x dash plus x, right? So this x was initially, and we do x dash operation, and in each operation we are increasing it by 1, and new y will be nothing but y dash plus y. And then if this multiplication is greater than equal to p, then what we will do is that we will just do answer is equal to minimum of answer. So like if valid, if this is valid, answer or x dash plus y dash, because this is the number of operation we did. So I mean this was just the brute force solution where you iterate on each possible value, like each possible number of operation on both of them. Okay, I guess I solved one via binary search. Are you talking about B or C? I mean, y is greater than equal to x condition. I think I like discussed this here, right? I already talked about this here. Like this is the condition, and I write that when y is greater than equal to z, then answer is -1. Bool CHK. R is equal to answer minus L, and int L1 is your code is slightly tough to understand for me right now. Okay, so you just did the binary search. Yeah, okay, this also worked. We will discuss it. So this was just the brute force approach, where what you do is that Find all the possible pairs of the operation you do on X and operation you do on Y. And you take the minimum, like the one which take the minimum number of operation. That's it. Also, there is one greedy technique. Okay, what is this? Uh, okay, so now there is a greedy way of solving this. The greedy way, let's say I tell you that let's say X is equal to 5 and Y is equal to 8. And now I want to do one operation on which you will do. Will you do operation on X or will you do operation on Y? Uh, so now like let's find this. So let's say if we do an operation on X, then X will be 6, Y will be 8, right? And if you do operation on Y, like Y plus plus, then X will be 5 and Y will be 9. So in this case, what is the value of X into Y? It is 48. And if you do operation Y, so like X into Y, in this case, it is going to be 45, right? So now you can see that this thing is increased. So this is more beneficial for us. So you can just do this greedy way, that whatever is more benefit, whatever gives you more benefit, you do that operation only. And why this will work? So there is also a proof for this. I mean, the idea is like this. Let's see all of the pairs. Like, okay, let's say like pair are like 1 and 4, 2 and 3. Then let's take something good. Let's say it is like 4, 4, 5 and 3, 6 and 2, 7 and 1, and 8 and 0. So let's say, so in this case, you can see that X plus Y is constant, right? But in this, the multiplication is 16, the multiplication is 15, this is 12, this is 7, and this is 0. So you can see that if the number are closer together, then we get a bigger result in multiplication, right? And this is like a fundamental result. Also, I mean, like maybe you have solved this in your JEE time, like when X plus Y is constant, X multiplied by Y is maximum when X is equal to Y. This is a condition. So, okay, this is the case. So, like you can solve it by greedily. So, like let's call it greedy one. This is nothing but you just check that which operation gives more benefit. And whichever gives, we do that operation. We do that operation. Right? This is one way. Also, there is another greedy way that I used in the contest. This is a greedy two. This is like first of all, I will try to make the values equal. Try to make, okay, and don't worry. I mean, maybe this both looks slightly confusing, but we will prove this and also dry run on the both of the logics, and you will understand that. So first, we will try to make both values equal, and then add like alternatingly. Okay, so these are like my two ways to solve. So like one way can we, let's take an example. Let's say X is equal to 5, Y is equal to 3, and P is equal to, let's say it is 48. So then what will happen here is like in the greedy one solution, right? We will find that, hey, is this like is the multiplication greater than equal to 48? No, because 5 multiplied by 3 is not greater than equal to 48. Now on which I have to do the operation? Should I do it on x is equal to 5 or should I do it on y? So yeah, we will check both. So if I do the operation on x, it will be like 6 into 3 is equal to 18, right? And if I do operation on y, it will be 5 into 4 equal to 20. This is better. So I will do the operation on y. So now, after one operation, my x is equal to 5 and y is equal to 4. P is still 48. So is this greater than equal to 48? No. Again, we will check that and we will find that uh, this is more beneficial. So we will do operation on y. Then x will be 5 and y will be 5. And P is still 48. Again, we will check. So the 5 into 5 is 25, which is less than 48. So we have to do the operation. So what we will do? Now you can see both are similar. So we can do operation on any one. So let's say we do operation on x. So it will be like x is equal to 6, y is equal to 5. Is our condition satisfied? No, because 6 5 is 30. Again we will do. So now we will do operation on this. So x will be 6, y will be 6. It is 36. No, we will again do the operation. X is 7, y is 6. No, then x is 7, y is 7, and yes, here our condition is satisfied because 7 into 7 is greater than equal to 48. So yeah, this is our greedy one will work. And also like you can see this is also what our greedy 2 is doing. First of all, I am making them equal, right? And after this are equal, I am just like adding 1 in x, then add 1 in y, add 1 in x, add 1 in y. That's it. So this was like my approach. Uh, x, so how do we come to know about which value will get increment? Okay, so like this was the greedy solution, right? I mean, whichever gives the more benefit, I will take that. Yes. So doing it on smaller is like adding larger num to the product. Yes, that's definitely right. I use the greedy. Okay, so that's a nice thing Jeder said. Like the point is that uh, if let's say x is equal to 7 and y is equal to 5. So if I add this, if I make this x is equal to 8, so then the product is increased by 5 only. And if I increase this, like if I do the y is equal to 6, then my product is increased by 7. Okay, let's just take this example. See, let's say I do the operation on x, then x will be 8 and y will be 5. So now x into y is 40. Initially it was 35. So you can see that this is increased by 5 only. But if I do the operation on y, so then x will be 7, y will be 6. The multiplication of them will be 42. So now we can see that this is increased by 7, which is a bigger amount. Okay, that's definitely a really good observation. Yeah, if this is clear, let's see the code. And okay, the code was also like very easy. So what I do is I use the like that alternating approach. I mean, first try to make the both values equal and then add the alternatingly. So first of all, uh, like I want that x is the smaller one. So therefore, if x is bigger, then I just swap them. After that, I know that the x is smaller, right? So until the x is smaller than y, I keep incrementing x. And also like if at some point, if my condition is satisfied, I just break instantly. Else I keep incrementing x. Then what to do? Then I know that we have to add increment alternatingly, right? So like we have to add like first of all add in x, then added y, then added x, then add in y, and so on, right? So therefore I use this technique. So see, if the condition is satisfied, break on that point instantly. Else, see, whose turn is this? Like if it is odd, then I know that it is the turn of x. And if it is even, then I know that it is the turn of y. Or you can also do the vice versa. I mean, this doesn't matter. So that's it. So like if it is odd, I incremented x, else I increment in y, and also this is answer plus plus. Answer is nothing but the number of operation I did. So yeah, and after this, I will break at some point, right? I will break at the point this condition is satisfied, and I will just print the answer. Yeah, that's it in this. That's in this question. And okay, first three questions were kind of easy one. I mean, but okay, where I can find this solved solution. Okay, same approach you solved only three and three. Okay, so now just like see next three solution very carefully because they are going to be very amazing. Same approach used. I don't know. My code chef was facing some issue. Yeah, same issue I got like initially till 15 minutes. Where I can find this solved solution? Okay, just after the contest. Sorry, just after this discussion, I will have this solution in the description, so you can find it there. Okay, it was just if x is greater than y, y plus plus, else x plus plus. Okay, yes, this is just the greedy approach. But the proof of this one was kind of nice. Just win plus. Oh yeah, the next one is also pretty easy. Yeah, this one is really easy. Like the fifth and sixth one are good. So let's move to the next question of our discussion, which is up down palindrome. Also, like please give me some feedback. Like how is the discussion going till now? And should I go fast or slow or something? Okay. Yes, let's read the fourth question. So we in this question we are given an array of length n, and we can choose an integer x. Then what will happen? See, then we will iterate on each index, and if the value on that index, if it is less than equal to x, then we will increment the element by 1. Else we will decrement the element by 1. Right. So let's say if this is the array initially, and I choose the x is equal to 3. So then what will happen? I will iterate on this array. I will see, hey, is this less than equal to 3? Yes. Then I increment it, right? Now I check, is this less than equal to 3? No. Then I decrement this. So 6 is become 5. And I will do that for whole array. Now we can perform this operation at most once. And we are free to choose whatever value of x we want. Then the case is that is it possible to turn the array into palindrome by performing this operation at most one? And if, yeah, the array is palindrome if this condition is satisfied. I mean, the array is same as the reversed array. And we just have to print yes or no. This is also a nice question. If let's analyze this. Let me, yeah. So this is our question D. In this, we are just given an array. Let's just take a test case. Let's say our array is like this. Let's say 3, and then there is also 3. Uh, there is 3, there is 5, there is 1, and there is 5, and 3, and no, let's 2 and 7. Okay, let's say this is our array. And now I want to make it palindrome. So first of all, what is the palindrome? So if you don't know, so in the palindrome, this first one, the first element will be equal to the last one. The second element will be equal to the second last element. The third element will be equal to this one, and this element will be equal to this one. So now, yeah, we have to make this pair same, right? This pair same by doing this operation. So how we are going to do this? So first of all, let's analyze like what the operation is doing on the element. like how the values are changing. So let's say there are two elements. Also, first of all, if the note this thing, like note this, like when the case is of palindrome, you just have to see the pair, like see them in the pair of values, right? I mean, you just have to consider this one and this one. You don't care about any other elements. You just consider this two. Then you consider about this two, and then this two. That's it. So let's say, let's take some different pairs, right? Let's say the values is like a comma b and x. So what are the all of the possible combination? Like one case is like a is less than equal to x and b also is less than equal to x. Then what will happen? Uh, so then we know that a is also incremented by 1 and b is also incremented by 1. So what is the difference between them? Uh, okay, just give me a minute. Okay, yeah, that's correct. What both of you are saying. Okay, so like in this one observation is that if this difference, right, like for this one and for this one, like for any pair, if the difference is greater than 2, then you cannot just make them equal. Why? Because see, you can change value by at most 1 only, right? So for a, you can just like reduce it or increase it. And for also the b, you can just reduce it by 1 or increase it by 1. So you cannot, like if the gap is greater than 2, you cannot do anything, right? Let's say the values are like 2. This is our area. Let's say 2 and 5, right? Now, what value of x you will choose? Like there is no way. Let's say you choose x is equal to 3. After that, my array will become 3 and 4. Still, you can see, like initially the difference was 3. Now the difference is 1. Like it is reduced by 2, right? It is reduced by 2. So this was our first observation, that you see the pair. There are only two possible cases. Uh, okay, let's say this difference. Okay, so if this difference is 0, then what will happen? Then we don't have to do anything, right? These both are same. Like the array is like, okay, so the pair is like 3 and 3. We don't have to do anything. I don't care about this. Like whatever value of x I take, these are going to be same, right? So here, whatever value of x can be there, we don't care. Let's say x is equal to 1. Then what will happen? Then this will be reduced by 1 and this will be reduced by 1. So this both will be 2, 2. Let's say x is equal to 5. Both will be incremented by 1. So this will be 4, 4. Still they are same, right? So we don't care about the same values. Let's say what if the difference is equal to 1? Can we make them equal? Let's say then example is like 4 and 5. See, now if you take any value which is less than 4, then both will be decremented, right? Let's say you take x is equal to 3, then both will get decremented. So it will be like 3 and 4. Let's say you take x is equal to 4. Okay. First, can the difference be 1? No, yes. It cannot be equal to 1. Uh, okay, this is it. If AI is less than equal to x, then I will add 1 to the x, right? Okay, so if x is equal to 1, so this will be added, so this will be 5, and this will be decremented, so this will be 4. Still the difference is 1. Let's say this is 4 and 5. I take some bigger value, greater than equal to 5. Let's say I take x is equal to 5. Now both will incremented by 1. So this will be like 5 and 6. Let's say you take x is equal to 6. Again, both will get incremented by 1. So yeah, there is no way such that when difference is equal to 1, you can make them equal, right? Let's say if the difference is equal to 2. This is the main observation, like main condition. Uh, so let's say this is like 4 and 6. Again, the point is simple. Let's say if you take any value which is less than 4, then both will get incremented, and I don't want that. One possible option is I take x is equal to 4. If I take that, then this will be incremented, and this will be decremented, and now this is correct. What is the second possible option? I can take x is equal to 5, and now uh, this 4 will get incremented, this will get decremented, and this is also valid. Let's say I take x is equal to 6. If I do that, then this will get incremented, and this also will get incremented. This I don't want. And any value greater than 6, like let's say I take 7 or 8 or anything, like the result will be same, that I don't want. So this is our main like observation, that there are two possible values, right? There are two possible values. One is that either x should be equal to a, or x should be a plus 1, right? Like this, or like this should be 4 or 4 plus 1. That's it. Or you can say instead of a, this will be like minimum of these two. Like this is 4 is minimum, so the possible one is 4 or 5. That's it. Any other value we will take, then I know that these two will be not same, right? So now let's say like the array is like this. This is 3, 3, this is 4, 6, this is 7 and 9. So now let's say you come here, you check it with this pair. These both are equal. We don't care about them. You come here and we say that difference is equal to 6. So then x can be either 4 or x can be either 5. If we take any other value, then we know that this both will not be same. So then this both will not become, so this whole array cannot become palindrome, because in the palindrome, every this pair is same. Okay, this is the case. And also like the third thing is, if difference is greater than 2, then there is no way, right? Then there is no way. That's it. But now how you are going to check that which value is correct? Uh, and the logic is, you don't have to think. Like you don't have to think in this, right? We don't have to think. Why? Like just do both operation and check. Just do both operations and check. That's it. So yeah, in the contest, like I wasted 5 minutes thinking on like which value to take. But the thing was like there are only two values, right? So just do the first operation, check if it is correct or not. Do the second operation, check if it is palindrome or not. And yeah, that's all you have to do. So did you understand this? Okay, so responding is saying I tried absolute is greater than 2, but I find some counter test case. So I did when AI it's not equal to, you have two options for x. X is equal to minimum or x plus plus. Yeah, that's correct. There are two possible options, and I'll check any of them is possible. Diff is 2, Still not working since X is either 5 or 5. So I go with that idea. Right. So like after taking the value of X, you have to check, right? That will it be okay? Yeah, I just forgot how you are going to check this. This is easy. I mean, checking means just do the operation on the array and then check if it is palindrome or not. Check if it is palindrome or not. That's it. So I hope you understand this and let's read the code. Okay, this is our code. So this is just the input. This is like the value of X. So this is just the possible value of X. And sorry, this is possible value of X. And initially it is -1. Then I iterate on each element. Okay, so if the indexes are like this, I iterate on each element. And so this A is going to be, let's say, this one. Then the B will be this. And in case if you don't know, like, okay, in case you don't know, like in the palindrome pairing is like this. So if this is 0, then the next, the pairing value will be the size, which is 7, minus 0, minus 1, which is 6. So this is the index, right? If we want to find which element is paired with 1, then it is nothing but n minus I minus 1, which will be 7 minus 1 minus 1, which is 5. So that's it. So like this A is, let's say, this one, then the B is the paired element, and like I want that A is the smaller. I mean, I have to find so I mean this is like slightly better. So after doing this, I know that A is the minimum one and B is the maximum one, right? If they are same, I don't care about them. Let me just remove all of this. Okay, if they are same, I don't care. Now, if the difference is 2, okay, if the difference is equal to 2, so what I do is I just say that, hey, one possible value is now A. And also, like, I don't have to write A plus plus, right? I mean, I just say that one possible value is A and just break there. So now, like, when I have to check, I will check for this value and value plus 1 both. Okay, so I just tell them that, okay, one possible value is A and just break. And if the difference is greater than 2 or equal to -1, okay, then I know that the answer is not possible. So like just as a flag, I do val is equal to -2 and break. So now I know that if val is equal to -2, then answer is no. And if val is equal to -1, this is also a edge case. So if val is equal to -1, then I know that I don't have to do any operation. So therefore, I just print yes already. Else, now I have to do the operation, like I have to do the operation of this val and also the val plus 1. So this is like the value of X. And check if any of like doing this, I will make palindrome or not. And for that, I have a already function. So this is, I just do the operation. I do operation. And after that, I check. So this is for checking the palindrome. Checking the palindrome. Yeah, sorry about my bad handwriting. So yeah, this is just the operation and I just make a flag and I just check, hey, is this pair same? If it is not same, then I know that flag is equal to false. This is not palindrome. And I return the flag. So yeah, that's it in this question, and I hope this is correct. Okay. I couldn't solve the fourth one. I don't know why. I since when I started learning DP, I think of DP mid hard ones. Okay. Yeah, that's maybe okay. Oh, there are so many charts. Thank you for replying here. So yeah, now check if they are same. Same goes for 5. 6 is also acceptable. No, yeah, it is not acceptable. Yeah. Okay, so okay, that's fine. I mean, if you want, so like in the contest, it is also important when to just get out of the wrong train, right? This is also the big problem I used to do. So therefore, like in my snippet, I wrote, I have this line already written like this, that think, observe, and exit quickly from the wrong train. So also like try to, instead of going deep diving into one topic, just try to first of all have a broad view. I mean, you think of different approaches and then only go into one deep, and also learn to disprove the things very fast. I mean, that will help so much. Yeah, if that is clear, then let's move to the best two question of this contest. And like they were really tough even for me. Okay, just give me a minute. Okay. So the name of the question is value flattening, and in this question we are given an array of length n, and each element is pairwise distinct. Yeah, and like to be honest, like, and also the AI is less than. Okay, no, sorry. Yeah, and all of the values are pairwise distinct. So what operation we can do is I can choose an index such that it is less than both of its neighbor, and then I will set both of its neighbor as the value AI. So one operation involves choosing element that's smaller than both of the neighbor and then overwriting the both of the neighbor with the chosen element. Yeah. And I can perform this operation however many times I like, and I have to find the minimum possible sum of the array after performing the operation any number of times. The n is still 2000, so you can solve this in O of n square or some complexity like that. And yeah, let's analyze this one. Okay, so this is our question E. So first thing is to, like in this type of question is to take a sample test case which is like good enough and analyze that one. So let's take one test case. So let's say our array is like okay. First of all, let's try to have see the sample test case. Let's say this one 52837 array 5, 2, 8, 3, and 7. So now let's like first of all see which of the elements are valid. Also, yeah, just like note this if the question includes something like less than or greater than or something like that, just try to think in terms of graph. So like this is 5, so this is 5. Then we reduce it, and this is 2, and this is 5. Then it is increased, so it becomes 8. Then it becomes 3. Then it becomes 7. So like it is like this. So on which values you can do the operation? I mean, see, I can choose this one because this is a value, right? This is less than both of them. And another is I can choose this one because this one is also less than both of it. These are my two possible values I can choose. Let's say I choose this one to do the operation. So what will happen after that is let's say I choose 2. So if I choose 2, I know that both of the neighbor will become equal to 2, right? So yeah, after doing the array will be 2, 2, 2, 3, and 7, right? And the another case is I choose 3. I choose 3. Then my array will become 5, 2, 3, 3, 7. Sorry, 3, 3, 3. Now, if you just analyze this one, there is no value. I mean, see, this is not less than both of it. Same for this, and same for this. So you cannot do any further operation in this. Let's analyze this one, and you can see that still this is value, right? This is still strictly less than this and this. So now I can still do the operation. So I can still like choose the 2, and after I choose the 2, I mean both of the neighbor will become 2. So my array will be 2, 2, 2, 3, 3. Okay, what's the final sum here? The final sum is 10 plus 6, 16. And here the final sum is 6 plus 6 sum is equal to 12. So this is like the better one, right? And also you can see that in the sample test case, the answer is 12. Okay, so in this type of question, first of all, you have to take some observation. And one observation was that also that is like not important, but one observation is that uh, okay, how to write this? Okay, so the observation is like the number of values will always decrease. So like see, if some element, if some element is not a value currently, then it will never become a value. It will never become a value. So this was like my first observation while solving the question. See, the point is that if it is not value, uh, and see, let's say the both of the neighbors will keep decreasing, right? Okay. Let me take a better test case. Let's say this one. So I know that uh, like the neighbors will only keep decreasing. So there is no case that this one is less than this two and this both after doing the operation. I mean, just play with the test case and you will find this. Okay, this was like my first observation. So then I know that the number of values will only keep decreasing in the operation. But now the question is which value I choose to do the operation first. Like which value or which element I should choose first to do the operation. And this was just the major observation of the question. I mean, that's it. If you can solve this thing, then the question is very easy for you. So just, I mean, try to think for this and give me a minute to drink the water. Okay. Yeah, sorry for the delay. Yeah. Yeah, let me know like if you were able to solve this, how you solve this question. Uh, I should draw a graph. Yes, so we can make a smaller value from before value to next value. Sorry, I mean I cannot understand this. Okay, yeah. So this was definitely a interesting question, and like what I saw from this test case is like, see, the smaller values, uh, the smaller values like this one can maybe destroy the bigger values, right? See, like if I choose the two here, so now initially this was the value, but now it is not the value. But if I choose the bigger one, they will never ever destroy the smaller ones, right? See, I choose the three and I choose the three. So even if I do the operation, this two is still a value, right? This eight is decreased, but it is just three. So still this is less than three. Then after that, I can choose the two and make that more decreasing. So this was like the intuition I got in the contest, and like maybe you can also solve this. Like the intuition was that, sorry, take the bigger value. So like for a second I got this intuition. Now the thing was to prove or disprove this thing. How you can do this? Or let's say you don't get this observation. So let's just try to play with some test cases. Let's say, so first of all, I know that there cannot be two values adjacent to each other, right? I mean, there cannot be thing like this is also a value and this is also a value. Yeah, this is obvious. Uh, Next thing can be like if the values are far from each other, I don't care about them. Let's say like this is one value, uh, and there is one value here, 3, 11 and 15, something like this. So this is one value and this is one value. If they are like far from each other, I don't care about them. I can just uh, modify them each other, like because they are not interfacing with each other. The only case was that when the values are near each other, like something like this. See, like this is one value and this is one value. What you can do this, and this is just like the test case we solved here, and the observation we got was that always take the bigger one. That's it. So from this, and after solving, like after taking some test case, and I was not able to disprove my solution. So therefore, yeah, this is our logic that like in the array, find the biggest value. Find the biggest value. What do I mean by the biggest value? So like if this is 2 and this is value with element 3, so this will be my biggest value. And do the operation on that one. Do operation on that one. And keep doing the operation until there is no values left. And yeah, keep doing this. So this was our logic. And I mean, so like, can you share in the live chat, like how why you were not able to solve this? I mean, maybe you got the idea of taking the bigger values and then you disprove this or like this. Yeah, larger altitude valley more prioritized than the sum of adjacents. Do you discuss problems you solved in contest? No, I solved them in contest. I thought of DP. Okay, That can happen. I mean, you just deep dive by solving this by the some other techniques, and then you got stuck in that. Yeah, that happens with me lot of times. But I mean, okay, so is there any doubt in the like how we got the observation? So that was all of it I did in the contest. I just like literally I just solved this sample test case. I found that maybe bigger values are good. Then I got the observation that I should take the bigger values because they are not like they don't they are not destroying the smaller values. So therefore we should take the bigger values once. That's it. And I think this code is very easy. Sorry. Yeah, if you have any doubt, you can just okay, nothing clicked, so I gave up. Yeah, that's really bad. I mean, for this, just like what I do is that even if I cannot solve any really sorry about this. Uh, okay, now is everything clear? Yeah, it was easy. Yeah, I mean, it was based on like if the observation clicked to you or not. No screen. Yeah. Now let's go to the. Okay, sorry. Yeah, I have to still discuss the code, right? Yeah. So this is our code, and this is very easy. So yeah, first of all, we there are t-test cases, and we take the input and all. Then what I do is I just go into loop. What I will do, I will find the biggest value. So this is like the index of it. This is the index of the biggest value, and this is the value of that index. So I start from the first index. Also, like see the fact this first and last element cannot be a value. So now if it is a value and it is greater than the values we found, right? This is the value. So if it is greater than the value we found, then I know that this is the maximum value. So I do the index is equal to I and value is equal to this, right? So after this, my index will point to the biggest value. Now, if the index is equal to -1, it means that there are no values left, no value left. If that is the case, then break the loop, else do the operation. And what happens in the operation? Nothing, right? If like this is the end and this is the value, what happens? This left neighbor and this right neighbor get the value of this one. So that's it. The left neighbor gets the value of the current one, and the right neighbor gets the value of the element at the index. So yeah, that's it. I mean, I found the biggest value. I did the operation and do this again, right? Keep doing this until there are no values left. That's it. And after that, what is I have to return? The sum of the array. So so my answer is nothing but the sum of the array, and I just print this. Yeah, I hope this was clear to you. And yeah, let's move to the craziest question of this discussion. This is moving blue boxes. So, okay, uh, why no TLE? Okay, this was like O of n square, right? I mean, see, there are going to be, okay, like see here. Yeah, sorry, like I forgot to talk about the time complexity. So, see, in the loop, right, for each value, what I'm doing, this is O of n, right, to find the value. And how many values can there be? There can be only n values at maximum, right? So there are n values at maximum, and for each value, I am doing n operations. So this will have time complexity O of n square, and that will work, right? Because of the constraints. N is still 2000 only. Can this be done in O of n? Yes. Like I got to know about after the contest, but definitely you can do this in O of n. What you can do is, uh, what you can do is like just instead of finding the value every time, just make a like store that in an array. So like let's say the array is like this. Uh, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Just find all of the values. Let's say one value is this one value is this, and one value is this. The 7. So just store them, store the index. So this is index 3, 4, 5. This is index 6, and this is index 8, right? And like for all of the values, store them into the decreasing order. So this is our first value, which is at index 8. This is our second value, which is at index 6. And this is our third value, which is at index 3. And now you do the operation from left to right. So you can do this in open. Yes, like that's right. Yeah, so now let's move to the next question. Okay, so also let me know like what observation did you get in the last question, so I know that uh, like till which point you came and what was the problem that you were not able to solve this one. So the question is moving blue boxes, and we have the n boxes arranged from left to right, and ith box has the value pi written on it. And then all of the values are pairwise distinct integers. Okay, that's just written to confuse yours. Like, see, the values are less than equal to n, and also they are pairwise distinct. So this is just saying that the values are permutation from 1 to n. Then initially, each box is colored red, and you can choose any number of boxes and color them blue. Then what we can do is, so like see, first of all, I just colored the some boxes as blue. Then I start doing the operation. So I choose two integers or two index I and j such that the boxes that are at position I and position j both are blue. And what I will do is I will cyclically rotate it. So like the box that was at position j will come to the position I, and all of the other boxes will shift one position. Okay, and also like colors are attached to box. So if the box is moving, then the color will also move with that box. Yeah. And now this subset is called good if coloring exactly this subset of boxes blue, we can sort this. I mean, we can do the operation sometimes such that it becomes sorted in ascending order. And I have to find the minimum possible size of the good subset boxes. Okay, this may be like slightly confusing. Let's analyze this here. So this is our question F. So what we can do is, first of all, we are given a permutation. So let's say our permutation is like this. Um, right, and now initially all boxes are red. Red, 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 and red. I can choose some of the boxes and make them blue. So let's say I choose this box and make it blue. I choose this one and make it blue. I choose this one and make it blue. And yeah, something like this. So now there are three boxes that are blue. After that, I have to make them sorted in the ascending order. Okay, so now let's say what the operation we can do. So like we can choose some I and some j such that both are blue and then cyclically rotate it. So like this will come here and all of the other one will shifted by one. So if I choose this, then my permutation will become 5, 2, 4. This 6 will come to here and all of the other boxes will shift by one. Also the color is red, blue, red, blue, blue, red, red, right? Now if you like more better, if you want to analyze this operation, this is nothing but it's like taking a blue box, like picking it up and putting it somewhere like in between, like taking a box and putting it just ahead of the one blue box, right? This is it. That's one operation, right? And let's say after doing some operation, it becomes sorted in the ascending order, then it is a valid, it is a good one. And the number of blue boxes we used is 3 for this test case, right? And yeah, we just have to find that what is the minimum number of blue boxes I can take such that after like doing the operation, I can sort it into the ascending order. Okay, I know that this may look slightly confusing, but yeah, you will understand that. Couldn't read, find it over complicating. Yes, this was. Okay, so now just forget everything. Let's just analyze one thing. Let's I tell you one thing. My permutation is like this. My permutation is like this. 1, 2, 3, 4, 5, 6, and 7. And now the operation I can do is nothing but I can take one box which is blue. I can take it and put it somewhere ahead of one blue box, right? And then I have to find if I can sort it or not. So let's say it is like this. This is blue, this is red, this is blue, this is blue, this is red, blue, and red. And so first of all, I have to make it sorted. So one operation I can do is like take this blue, take this and put it somewhere like here, right? Or another operation I can do is like take this one blue element and put it just ahead of this one blue or something like this. So now can you just find what is the, like, can you find that uh, if some box will always be blue or not or something like this? And see, the observation was that here, this is like one, okay, and this one, okay, and also like note this thing, note this. Okay, let me change the color. Uh, it is like better to think in like think for minimum or maximum element mm, in the contest. Okay, this, like, by doing this, maybe you can get some observation. So here the observation was that, see, here it is 1, right? Now, you take any of the other, like any other operation. Let's say you do this and move it here. What will happen of this? This will just move one position in right, right? Let's say, so there are only two cases. Let's say you take something like this, you do operation on this. There will be no effect on one. Or you do some operation like this, where you take this 4 and put it here and shift everything. If you do something like this, then this one will go one step into right. But what we want is, we want the one into the leftmost position. We want one is here. How we are going to do this? So from this, like, the idea is, for sure I can say 100% I can say that this one will become blue. And then I will choose something like this, and then this one will come to this first position. That's the only way. Okay. Like, see, let's say my permutation is like this: 1, 2, 3. Yeah, let's say this 4. And let's say this is blue, this is red, and all of the other are blue. Still, there is no possible option that you can move this one at the first position. There is no, if it is red. Like, what you can take? Let's say you choose this thing. If you choose this, so this will come to first position 3, and all of the other will be shifted. And yeah, also the color is like blue. This is blue, this is red, and this is blue. I mean, see, let's say then you take this one. Then what will happen is, these two will be get shifted, right? So let's say if you take this, then it will become like this. Still, there is no effect on one. So the idea is that one will only go to right if you don't choose it. If you want one to be at the first position, you will have to take the one and put it in the here. So therefore, compulsory this will be blue. This was my one observation, right? Also, see for the two, right? For this two, it has to be come, like, it have to jump this 5 to come here. Is this clear? So therefore, compulsorily I can say that this one will also become blue. Let's say for this 3. This 3 wants to jump the 6 and 5 both. And for to do that, for sure I can say that I will, like, choose this 3 here as a J. Right, this is I and this is J. So I will choose it as a J, and then and only then it will come into left. Right? So therefore, I can say that this 3 will also be compulsorily blue. Right? So, like, this was my first observation while I was solving. See, okay, the first thing is that instead of, like, thinking of operation like this, like cyclically rotating, think of them like this, right? You are taking one and just putting it somewhere into left. That's it. So the observation is that, uh, for, let's say, for element I, there is someone in left. There is someone in left of it, which is greater than, which is greater than the current one. Then the current element, this is the ith element, okay, will be blue for sure. Why? I mean, see, like, I already talked, right? I mean, let's say this is it. So now if this one wants to jump this 4, I have to take this one and put this ahead. That's it. Like if I keep choosing some other elements, then this one will never be ahead of this 4. So this will never be sorted. So this was my first observation. Like that for element I, if there is someone in the left of it which is greater, then I know that this is the blue for sure always. Else it can be red or it can be blue. I am like we are not talking about that. So now let's take an example and then also try to find some other observation if you can get. So let's say my permutation is this, like 3, then 2, 1, then 5, 4. Okay, that's it. Now, for what I can say? I can say that this one will definitely become blue for sure, right? Because it has to jump this 3. For this one also, I can say that it will definitely like always be blue. For this 4, this one will also be blue because it has to jump this 4. Okay, that's fine. Now, like, uh, can we find the solution for this? Like, if these 3 only are blue. Okay, yeah. Like before this, let's take the smaller test case. Let's say my permutation is just 2, 1. What will happen? Yeah, both of them have to be blue. That's for sure we know. If they both are blue, then we will take it and put it ahead of it. What if the permutation is like 3, 1, and 2? Then what will happen? Oh, and let's say this is 4. This have to be blue, this have to be blue. But like to do the operation, right, it has to jump. But there should be also somewhere in left which is blue. Like because in the operation, right, this ith element should be blue and jth element should be blue both. So therefore, this one should be also blue so that it will jump here. So after that, what I can choose is that I choose this 2 and I put it ahead of this 3 because this 3 is also blue. So now my permutation will be 2, 3, 1, 4, right? This is blue, this is blue, this is blue, and this is red. Then I choose this one and I put this ahead of this blue element. So now this will be 1, 2, 3, 4. This is sorted. So yeah, the observation is like these are compulsory blue and there should be also one element which should be blue so that they can jump. Okay, this was my observation. And yeah, then in like excitement, I just code it and got the wrong answer. Okay. Can you find what is the problem in this? So like what my logic was initially, I just so like I just found the number of elements which are less than its prefix max. And then I just printed this answer plus 1. Why? Because I thought that like see, these all are compulsory blue and there should be one which is blue so that I can jump. But yeah, this did not work and I got my wrong answer. Rating of value in CF, starting with 1 itself. I think that rating will be like, it should be around 1300 because it was slightly tougher. What I did in value equation, I greedily expanded the largest possibility first and repeated it n time it worked. Can you please explain what does you mean by largest possibility? Okay. Okay. Yes. So as I said, this was my first observation. Uh, okay. Let's also uh, talk about the second observation of this. See, the observation two is that for all of the red balls, uh, the relative order can't be changed, cannot be changed. So like this was my second observation, and so let's say you just try to play with some test case. Okay, let's say the array is like 1, 2, 3, 4, 5, 6. Now, sorry about this. Ah, okay. Yeah, everything is clear. Okay, so let's say it is like 1, 2 here, 3, 5, 4, and okay, this is it. So let's say this is red, and this is red, and this is red. So see, like for the blue balls, let's say there is one blue ball here. I can just put it here and let's say put somewhere else. I can just take the blue ball and put it somewhere else. But you can see that for the red balls, I cannot put it because they are red. So therefore, their order cannot be changed. So yeah, one observation is that the order of the red ball is should be in increasing order because it should be sorted. Yeah, but this doesn't matter much. Now let's go to the main observation of our question. Okay, let's see some test cases. Let's see permutation is this 2, 4, 1, 3, 6, 8, 7, and 5. Okay. Can we find that which ball will be blue by for sure? So I know that this is for sure blue, right? Because it has to jump something. This is also blue because it has to jump this 4. This is red, like this can be red. Okay, this is for sure blue. Why? Because it has to jump this 8. And this is also for sure blue, right? So now I can see that they can be red, right? They can be red. So now let's just uh, write this. Okay, so let's say these are my red balls. These are my red balls, and I cannot change the position of it, right? And there are some my blue balls. There are some blue balls. Let's say this is blue, and there is 7 and 5. Okay. Now the point is like there are sections between the red balls, right? I mean there are some sections. Like one is this one is this one is this, one is this, and one is this. And now I want to like change the balls. So thing is like see, this is the one, and I want to like move it here. I want to move it here. Can I for sure say that for that? Like this is blue, that's okay. But this one should also be blue. Why? Because if that is true, then and only then I can choose this and this one comes to this. So like this is my one observation. See. So therefore this must be for sure blue. So this is like blue. Then and only this, after this, I will move this one here. Okay, so let's move this. Now let's say of this 3. So this is a 3. This wants to come in here, like he wants to jump this 4. Can he jump it? Well, you can see that this is red. So you may think that no, it cannot jump. It cannot come here directly. But it can. Why? Because see, the point is, sorry, let me just remove it. The point is, if you choose this 3 and this 2, let's say you choose this subarray, then this 3 can come just ahead of this 2. So what will happen? Sorry, what will happen? This 3 will come just before the 2, right? It will be something like this, and now you can just change it. Now you can just change it. So they will become 2, 3. That's sorted, right? So the work of this section is clear. So the idea is that, see, now comes to the like main observation. Let's say there is some random element. Let's say it is 9. Okay, just assume that like there is one section. Now there is some element who wants to come in this section. What is the condition for that? This is like main observation. See, if it wants to come to this section, there are only two possible ways. One way is that either there should be some element which is already blue in between, right? If that is true, then you will just call it like you will choose this, and now this 5 will come at here, right? Or the like the second case is this should be blue. You cannot make it red. So now like this should be blue now from now. So this is like the observation. This is our third observation. Like if you want to move something in, let's say section, let's say section is like there is X and there is Y here. This is also red. Sorry, this is, so either there can be something in some blue ball in between, or this Y should be blue. This is like my observation 3. Because if that is not true, then there is no way I can move this 5 to here in between 4 and 6. Uh, okay, because like, you can see like there will be no blue ball that can come to here because this is red. Yeah. So like this was the third observation. I mean, I hope you understand till now. What's your rating? It's 1900 and 8 in the code courses and Guardian not lead code. Okay. So see, like the intuition, like in the contest, like I thought is like, sorry for saying like too many times. So there are some red balls which are constant at that position, and I can choose someone here. And yeah, then I got that if I want someone, like if I want something to be in this section between this, what is the condition? And I got this condition. Okay. So now I think this becomes easy, right? See, what is the logic? The logic can be something like, first of all, change it into red balls and blue balls. I mean, see, let's say if the permutation is like this, 2, 4, 1, 3, 6, 8, 7, and 5, find that which balls are blue for sure. So this one is blue for sure, this is blue, this is blue, and this is blue, right? So convert this into sections. So now I know that the red balls can be like this, and these are the blue balls. These are the blue balls. Now what I want this one. to jump here. I want this one to jump here. What is the condition? The condition is there should be some blue ball here. If there is some already blue ball here, I can just use that, right? Let's say if there was 9 here, that is blue. So I just choose this 1 and 9, and now then 1 will come to here, just ahead of 9, right? But this is not true. So now I know for sure that this 2 will become blue. This 2 will be blue, right? So let's make it blue. So let's make it blue. Okay. Can you see? Okay. Can you see another main observation? The point is that if I make this blue, then the thing for the next one is also clear because there is someone ahead which is blue, just ahead of this 2, right? Sorry, just ahead of this 4. So now what will happen is I will make it blue. Sorry, I will make it blue. Choose this one and put it ahead of this 2. I will choose this one here and I will put it. Now comes the thing of this 3. Again, like see, I will check for this 4. This 4 should be red or there should be some blue element in between. Yes, there are some blue elements. So I will take this 3, put this ahead of this 2. Okay, and like, yeah, and this in between can be sorted easily, right? I mean, I can just, then I can just take this 2 and now this will come here. So it will be sorted like 2, 3. So yeah, also the thing is, I don't care the blue values in between one section. They can be sorted easily. Now let's say I go to the next value. I check again that, hey, sorry, this is 5, right? Sorry about this. So, okay, I go to this 5. I want to move it here. And now like at this point, you may think that maybe we need maybe we need to make it blue, right? Because there is no blue element in between. But you just forgot one thing. What? The point is that can you say that initially, in the initial stage, there was 1 here and there was 3 here. Both were blue, right? Both were blue. So, and yeah, like they both then moved to this section. But initially they were here. So I can like use them initially, right? So what I could have done is, see, in the initial case, when the things were like this, 2, 4, 6, 8, and yeah, the values were like this, 1, 3, 7, and 5. I can just like, even before solving this, I can move it here by this use of 3. So therefore, okay, yeah, let's remove this. So therefore, the 5 can come here. I don't have to make it blue. I don't have to make it blue. This 5 can easily come here. Then I go see the case of 7. Then I see that, hey, in any case, at any point of time, was there any blue here between 6 and 8? No, there was no blue here. So therefore, I have to make it compulsory blue. Okay. Yeah, this 5 came here and there is 7. So this 5 have to so this 8 have to compulsory blue, so that then and only then the 7 will come here. Okay, yeah. I know that this observation were kind of really confusing, but just like try to play with them and you will solve this. You will understand that. Okay, is becoming expert needs practice or born brilliant? I don't think that it have to be like you have to be brilliant. Uh, you can just do a simple practice. Just read the blocks, solve the question, and absolve every contest. And yeah, That's it. According to your rating, last two question, I think the fifth one should be around 1300, or this one should be around maybe 1700. Not sure. Okay, so like this were our test the observations, and then you can just play, right? What you can do is see. That's it. Like first of all, let's say you have some array. Let's say there is like this: 1, 2, 3, 4, 5, 6, 6, uh, 7, 8, 9, and 10. Let's have 10 here and 1 here. Yeah, this is better. So yeah, first thing is make the balls like which are compulsory blue. So this is blue. This will be for sure blue. Okay, yeah, there are so many blue elements. I don't want that. Let's just swap this and swap this. So this is 9. Sorry, this is 9 and this is 5. Yeah, this is better. Okay, so this is compulsory blue. This is compulsory blue. Sorry. Then this is blue. This is blue. This is blue and this is blue for sure. So let's break it into two parts, right? Let's break it into two parts. The red balls, so this 5, 7, 9, and 10. These are the sections, and between them there is 4, 3, there is 2, 1, there is 6 and 8 here. Now the point is that you can have some thing like, okay, now the observation is that, see, if you want to move anything between this section, you can do that easily. Why? Because there is 3 and 4, right? So let's say you want to move the 6 here, just move now. So like 6 will be here. I mean, what you can do is select this 3 and select this 6, and the 6 will come here, right? So yes. So the thing about this section, and this uh, section is clear. So like if you want to move anything here, you don't have to make it this one blue. That's it. Okay. Then just keep doing the operation. What you can do is you take the smallest one, you try to move it here, and okay. For that, you see that, hey, is there anyone, or I have to make this one as blue? And you find that sadly I have to make this blue. So I make this as blue. I make this as blue. Then I change this one to initial point. So like the one will come here. Then I go for 2. I have to move this here. Like first find that in which section it has to go. Then if this is blue or there is some blue below, you will just move it here. Right. You will move to 3 here. You will move 4 here. Then you will see the case for 6. Okay, let me remove this and write this properly. So this will be 1, 2, 3, 4, and 5. You will see the 6. You will see this. Hey, is there any blue ball ahead, or is this is blue? Yes, there are some blue balls. So you don't have to do the operation. You will just move the 6 here. That's fine. Then you see the case of 8. Then you find that in which section the 8 belongs. 8 belongs to this section. Sorry. 8 belongs to this section, this between 7 and 9. Now, can you move this? Yes, you can move this because initially at some point there were some blue balls. So what you can do, okay, this may look confusing, but what you can do is that before doing the any operation for this, before doing any operation for this, why not we do the operation of 8, right? So see, initially when the array was like this, uh, okay, sorry, like when the array was like this, when here there were 2 and 1, initially why not you can do this operation? That's it. So yeah, the logic is something like this, and there is also some one important point. The point is that, see, if you make this section, okay, this was the red ball, right? If you make this one as blue, the case for this one will also be clear. I mean, because uh, then you can say that for sure there is some blue ball ahead of this one. So why not you can do something like this? Okay, I know this was so confusing. So yeah, my red balls were like this, 5, 7, 9, and 10, and there were my blue balls, 2, 3, 2, 1, and sorry, of course, 2, 1, and 6 and 8. So let's have a vector called check. This vector will tell me that can I easily move this blue ball here, or I have to change something, like, so like initially here the check will be 0. I cannot move anything here. If I want to do that, I have to make this one as red. For this, like for this section, okay, this was for this section. For this section, the value of check will be 1. Why? Because there are some blue balls in between. The value for this section will also be 1, and for this one it will be 0 because there is no blue ball here, right? Now I see the case for 1. When I want to move 1 here, I have to make this as blue, right? I have to make this as blue. So then this is blue and my check will become 1 because now I can easily move anything here. I don't have to do extra operation. That's it. So yeah, that's just the logic. And also the slightly another thing, which is, let's say this is like my blue balls, right? And let's say it is like this, 1, 2, 3, 4, and 6, 8. Okay. So now initially you can see that for this, the check is 0. Here the check is equal to 0. Here the check is 1. Here the check is 1. And here also the check is 1. Now, if you make this one as blue, if you make this is blue, then check for this will become 1. And also the check for this section will become 1. Why? Because see, there is a blue one here. There is a blue ball here ahead of this 7, right? So now you can easily put anything at this point. That's it. So this is just the extra point. So now let's see the logic. The logic. It is nothing but, first of all, find which balls are compulsorily blue. Sorry, blue. Then what we do is break it into sections. And after that, for each blue ball, try to put it in its valid section. Okay. So now let's read the code and you will understand this clearly. So this is my code. So yeah, till this is, I just take the input of the array. Then what I do is I break it into two parts. One is the values that are done and the values that are not done. So the values that are done means that they can be red balls, and the not done, which means that they will compulsory be blue. Compulsorily, they are blue balls. This thing. Okay, so now let's try run this on a test case. Let's say my test case is this: 2, then 4, 1, 3, 6, 8, 7, 5. Okay, let's say this is my array. So then what I will do is like for all of the for all values that are blue. Okay, so let's say this is compulsory blue, this is blue, and this is blue, right? So I will break it into two arrays. One is the done array, which is nothing but the values that are red. So the values that are red is 2, 4, 6, and 7. And also in the not done. Okay. Also there is a chk. There is a vector chk. Okay, we will talk it later. And there is a not done vector. Sorry. There is a not done vector. It will show nothing but the values that are blue. So this is 1, 3, 7, and 5. That's it. So now, like, can you see that these are my sections, right? This is red. This all are red balls. And I will take one and I will try to put it into according section, right? Like I will take this one and try to put it here. I will take, that's it. So what I do is, see, if the prefix maximum is greater than the ARR of I know that there is some value which is bigger than it, right? I mean, see, like when I am here, the prefix maximum will be 4. So I know that this will be compulsory blue. So I just put it into the not done. Else I will put it into the done array. Okay. And also I have a check array. I have a check array. What it means is that, yeah, we already talked about it. It will be either 0 or 1. It will just show that, hey, is there any blue balls ahead of this? Or is there any blue ball in this between 2 and 4? That's it. Initially, it will show that. So, see, to count this, I have like the well ahead. This is nothing but blue balls ahead. And see, if this is a blue ball, I do the well ahead plus plus. Now, if there is any blue ball which is in this section, I will put 1 here. That I don't have to change any other balls to red. Else I have to put it like I have to push back 0 in the check. And after that, my well ahead will be 0. Like it will be just reset. So see, you can say that before this 2, there is no blue ball. So this will be 0. Before this 4 also, like between this, there is no blue ball. So this will also be 0. In this section, like, sorry, between 4 and 6, there is a blue ball. So this will be 1. And same for this, here it will be 1. So this just tell me that if anyone wants to come in this section, it can come easily. That's it. So yeah, that's it. I am just breaking it into the section. And then I just sort the values because these are the non-done, right? I want to iterate them into increasing order. So like after sorting, this will be done. Now this comes the main point. Okay, see, I iterate on this not done array, like the array, like the element which are all are the blue. First of all, I do answer plus plus. Why? Because this element is blue, right? So I do answer plus plus for that. The current element is the value of this is this one, right? Current. Now I have to find that in which bracket this will come. So see, let's say my done array is this. My done array is this one, 2, 4, 6, 7. 2, 4, 6, and 7. Now I have to find that in which section this 1 will be here. 1 will be at this point. So yeah, you for finding this, you can easily do the upper bound so that it will give the result in O of log n only. So you do this, you find the index of it. So this is the iterator and the index of this will be this. Now what you do? This is the main point. We check that, hey, like see, if the check of index was 1, if the check of index is 1, then I don't have to do anything, right? I don't have to do anything because I already know that there is some blue balls in this point. Sorry, like there is already a blue ball in this section, or this ball is blue. But if that is not true, if that is not true, so what I will do is I will do answer plus plus and I will make that ball. Sorry, I will make that ball as blue. But if I make this as blue, then the thing of the next ball will also be clear, right? Because there is some blue ball ahead of it. So that's it. I do the check of int is equal to 1. And also you can here have the int size, but both sides are same, so it doesn't matter. And so the check of current will be 1 and also the check at the next index will be 1. That's it. And I keep doing this and yeah, we get the solution. So now let's try run this. Okay, so let's write our test case again. My permutation is nothing but 2, 4, 1, 3, 6, 8, 7, and 5. Now we will have a done array and a check, and we will have a not done array. This is the first element. So there is like no one ahead of it. So like this will come into done and the check will be 0 because see, the well ahead is 0 initially. And if well ahead is 0, I push back 0, right? So that's it. And now my well ahead is 0. And also what are the other variables? Okay, other variable is MA, max. Max I got is 2. Then I come to this one. So yes, this is greater than the maximum. So it will come into the done array. And the maximum will be 4. And while it is 0, so the check will be 0 and again I will clear it and make it 0. I come to this one. I see that, hey, is this greater than equal to 4? No. So I know that it has to be blue. So it will come here. And I do while ahead plus plus. So I mean there is one blue ball. I go to this. Again, this will go added into the non-done. I do while ahead is equal to 2. I come to this. So this is greater than 4, right? So this will come here. My well ahead is 2. So again, check will become 1. And this, I will clear this. And yeah, the maximum will be 6 now. I see this one. So 8 will come to this. Well ahead is 0. So this check will be 0. I come to this one. It will add it into not done. And this also will be added into not done. So after all this, I don't have to do anything about this well ahead and this. And I will sort this not done. So after this, my not done array will be 1, 3, 5, and 7. Then what I do is I iterate on each element. Like say, I iterate on each element. I do answer plus plus, so answer is equal to 0. I do answer plus plus 1. I do the lower bound. So lower bound will give me index 0 because this is the bigger element. And the check is 0 initially. So what I do is I do answer plus plus again. I make this as 1. So make this as 1, and I also make the next one as 1. Okay, that's it. And then I come to this 3. I again find that in which section it comes. It comes in this section, right? This is 1, so I don't do anything. Sorry, I mean, for this will 0. I come to this 5. I do answer plus plus. I find that in which section it comes. It comes in this section. And yes, the check is already 1, so I don't have to do anything. Then I go to 7. I find that in which section it comes by upper bound. It comes in this section. And yeah, the check is 0, so I have to do the answer plus plus. So yeah, the answer will be 5. Sorry, 6. So that's it. So I hope you understand this. From question C, I did not understand much. Like I just started coding about 1 month ago. That's okay. That's fine. I mean, just make sure that you upsolve this, and if similar question comes into the contest, you are able to solve this. It's a request. How to be pro like you? Well, like I'm not pro like Asia West finalist. So yeah. So that's it till now. And if you have any doubt, you can share it into the live chat. Uh, okay, yeah, this discussion was very lengthy. This looks tough. Okay, yeah, this was a very tough question. I mean, you can just skip the F question if you are just beginner, but always like solve the +2 questions. V777. So like, do you want to analyze your profile? Uh, okay, let's analyze it. Why not? I hope this is clear. V777. Okay, okay, this looks great. I mean, you are not able to jump this newbie range, right? Uh, this looks good. I mean, you have solved enough questions. Then what is the problem? Okay, you are till 1300. Okay, I mean, your question solving looks good. Just try to solve this 1300 and 1400 questions more, and you will see the result. The thing I can see is that you are doing valid hard work, and this is very nice. I mean, I can definitely say that you are a pupil for sure. Just that it is not looking into the contest rating, but you are pupil. Uh, I mean, sooner or later you will become with that. Yeah, that's like really good. Just keep practicing 3, 4 at least question every day, and you will see the results. Also, the point is that see, if you are like if you will solve 50 question of the 1300, you will become pupil easily. When you will solve the 50 question of till 1500, you will become a specialist. That was the case in my solving. Okay, you can share your profile. Noble still 56. It is Noble still 56. Are you sure that is correct? Okay, I cannot find your profile cube decoder. And also, yeah, thank you so much, Reese Coding and Cube Decoder, to be in the discussion for being in the whole discussion and making this discussion interactive. Yeah, also, please, can you share your profile again? Or I think I did some mistake. Noble Steel 56. Okay, yeah, your profile is okay. It is on CodeChef. I don't know how to find the profiles on CodeChef. Okay, yeah, I mean just share it into the comment section, and I will analyze it and will tell you. I can solve two, but took one and two wrong answer in two. Okay, I mean that happens. Also, the thing you can do is make a notebook or Notion or something like this to the store. Let me show you my Notion if it's correct. Uh, yeah, I think it. No, not this one. Okay, okay, I will share that next time. So, how many questions you should solve daily? Aim for at least 3 to 4 questions, and also like if you are solving into code forces, after solving 50 questions for one particular rating, jump like see like after solving, let's say you solve 50 of 1400, then solve for 1500 only, and also read the blocks in the beginner stage. That helps a lot. Read some like read STL and book like TP handbook. They will help a lot in beginner stage, and yeah, that's it. So when to watch tutorials? Okay, there are like so many good blogs on the code courses. You can read on that. I haven't tried code courses, just using CodeChef for now. Okay, I mean that's fine, but I feel that code courses and Coder are good. CodeChef is just I feel that it is around one particular type of question of some DP or combinatorics. While in code forcer it is like ad hoc question, and in I like ad coder it's the best one. Yeah. Also, okay, you can read the blocks and you will understand that. So yeah, let's end the discussion now. It's very late, and thank you so much for being here, and meet you in the next live chat.